Solve the following system using Gauss-Jordan elimination or Gaussian elimination with back substitution. I intend to use Gauss-Jordan elimination, but if you use Gaussian elimination with back substitution, you will end up with the same answer. The first step here is we need to change this system of equations into a matrix. And by that method, I'll have the x's in the first column, the y's in the second column, the z's in the third column, and then the answer, which I call this part of the equation over here, just these numbers all alone, in its own column. So we are just taking the coefficients. So the x coefficient in the first equation is 1, and the second equation is 2, and then the third equation is 2. The y coefficients, we can write something similar for those, and the z coefficients, so we can write something similar for those, and the answers are 2, 1, and 5. The idea here is for us to get zeros in the lower triangle of this diagonal and zeros in the upper triangle of this diagonal. And in order for us to do that, we need to use row operations. The first step here is to make sure that we have a 1 in the upper left-hand corner of our matrix. It's already there, so we can move on to row operations to eliminate these 2's underneath this 1. In order for us to do that, we will need a -2 to eliminate each of these 2's. So how can we do that? We can multiply -2 times row 1, we can add it to row 2, and we can store the answer back into row 2. So row 1 is 1, -1, 1, and 2. If we multiply all of those numbers by -2, we will get -2, +2, -2, -4. In row 2, I will write just underneath that, just as it is. We're not multiplying it by anything. And the answer, what we will get down here after we add everything together, will go back into row 2. So if we add these two rows together, we will get 0, 3, -3, and -3. We need to do the same thing with row 1 and row 3, so we are able to get rid of this 2, or turn it into a 0. And we will do the similar operation, so -2 times row 1 plus row 3, we have this -2 times row 1 from our previous information, and row 3 looks something like this. So when we add these together, we will store it back into row 3, and we will have 0, 0, 0, and 1. So the new matrix will look something like this. 1, -1, 1, 2. We will have 0, 3, -3, -3, and we will have 0, 0, 0, 1. And something about this answer is peculiar. If we go back and think that the first column was the x's in each equation, and the second column were the y's in each equation, and the third column are the z's, and this is the answer, we get something really strange with this last row. That is 0 x's plus 0 y's plus 0 z's equals 1. This is impossible. So this tells us right away there is no solution to our system of equations, and we call it an inconsistent system of equations. And that is your answer.